This is a problem of geometry and it is of moderate difficulty level. Here it is given that A0, A1, A2, A3, A4 and A5 is a regular hexagon which is inscribed in a circle of unit radius. So let's draw a circle first and then draw a regular hexagon. So figure would look like this, and we have to find the product of lengths of line segments A0, A1, A0, A2, A0, A4. So suppose this is A0, this will be A1, A2, A3, A4, A5. As in case of regular hexagon, all sides are of the same length, then or which means the angle subtended by each side at the center of hexagon, which will be the center of circle as well, will be the same, and the total angle that can be drawn at a center is 360 degree, and there are 6 angles, so value of each angle, like A0O E1 will be 60, and same will be the case with other angles, like E1 O E2 will also be 60, and so on. And as A0O and A1O are equal, which means angle A0 as well as A1 will be 60 each. Here we have to find length of A1, A0 A1, A0 A2, which means this length, and A0 A4, which means this length. Now it can be noted that A0 A2 and A0 A4 will be of the same length, and A0 A2 will be nothing but the twice of height of triangle A0 O A1, as A0 A2 will bisect A1 O. So first of all, find the length of A1 A0. From the figure it can be noted that A1 A0 will be equal to A0O or A1O, as A0 O A1 is a is an equilateral triangle. So the length of A1 A0 will be equal to the radius of the circle, which is of unit radius. So A1 A0 or A0 A1 will be equal to 1, and A0 A2 will be twice height of A0 OA, which is a triangle, and we know that height of a triangle which is in shape of equilateral is root 3 by 2 into side of the triangle. In this case, the length of side is 1. Therefore, a0 a2 will be root 3, and a0 a4 will also be root 3, as it is equal to a0 a2. And now the product of a0 a1 into a0 a2 into a0 a4 will be 1 into root 3 into root 3, which is equal to 3. Therefore option B is the correct answer.